So my name's Darren. I work for the New York Times games team. I'm a Go developer. Yeah, and my company fails every single day. All right, so here's the setup. The background is we recently completed a huge overhaul of our gaming platform where we moved it from what is essentially a LAMP stack to all on GCP. So the setup is we have data somewhere, and we need to move it somewhere else. In this case, we're actually moving it from data store to BigQuery. All of our data is in data store. It's our source of truth. And it's great for application data. You can say, hey, give me today's puzzle, or hey, give me this user's progress. But marketing would come to us and say, hey, what's the average solve time for today's mini crossword? But we have a lot of data. We store all users' progress. We take snapshots of everyone's progress as you play the game. Every snapshot has an entire copy of the board on it. So this data gets very large. We have several terabytes of specifically progress data. Plus we have puzzles, we have scores, we have all sorts of other stuff. So we have to move it. So the first solution was Google has a built-in, basically Mapreduce Framework where you can create a backup of your data from data store, put it into GCP. But this had a number of problems. First of all, when you kick this off, it basically kicks off a bunch of Python-based MapReduce jobs in the background of App Engine. These run on your default service. Every GCP project in App Engine has a default service. In our case, it was our Edge server. So that set off all sorts of bells and whistles as the average latency of our Edge server went from like 40 milliseconds to 10 seconds, as these things were just in the background churning, trying to move our data around. So it was way too slow. We found that they moved about a day's worth of data over the course of 12 hours, which is way too slow. We have years' worth of data. And it's not very flexible. You know, you kick it off, it loads the data, but you can't really do anything besides that. So someone has written an existing thing in Go to replace Google's Python implementation of the Mapper framework. It's written by a guy named Captain Codeman. I don't know who he is. We looked into his code, decided it didn't really fit our needs either. It's third party, it's not very extensible, but the thing I want to point out is that he managed to get up to 1.6 thousand entities loaded per second. So that's the thing to beat. So let's write our own. And we want it to look kind of like this, where you could hit an endpoint with an HTTP GET with some parameters, say like a start timestamp and an end timestamp. Say I want to load yesterday's data, maybe a limit just to test it. And that should kick off the job to move our data. And that's kind of what the endpoint looks like in code. It accepts a GET request, calls this load scores function, and works. So that's kind of what it looks like. You have an HTTP request, grab the data from data store, put it into BigQuery using an App Engine instance. But again, we have a lot of data, so we want to move a lot of data around, and so a single instance isn't going to cut it. So we designed this algorithm. So a request comes in for a certain type, just like you saw. We query for all the keys, not the entities, just the keys. And then we're going to start publishing the keys out to PubSub. And the cool thing is that you can actually, the instance that we kicked it off on, it actually subscribes to this PubSub topic. So all of those PubSub requests actually flood back into that service, and it automatically scales itself up, uses those keys that are incoming to query data store for the actual entities, say in batches of 500, and put those into BigQuery. So this is kind of what it looks like. Please excuse my janky diagram. An HTTP request comes in. We start publishing out the keys to PubSub. It scales itself up, and they all do batches of gets and puts. And this worked pretty well. It's fast, but it's not that fast, because this original instance that took the original request, it has to publish every single key. And if you give it, say, load the last month's worth of data, that could be millions of keys. So, and an HTTP request in App Engine only has 60 seconds to complete. So sometimes this would die after 60 seconds, having not published all the keys that we needed to. So Now we got to design a new algorithm. So if a request comes in for a large range of data, we want to divide them. We want to divide the query by date. And now we're going to use task queue in the middle. We're going to have a two-step fan out. So we start publishing date ranges to task queue. The task queue tasks come back into the service. It scales itself out initially. And then those queries start publishing the keys out to PubSub. And we do the same thing we did before. So this is kind of what it looks like. If the request time frame is larger than, say, an hour, or we didn't give it a limit, we want to create a publisher. We can initialize the tables in BigQuery for us using a type as the schema. And if it's within, say, 1 hour, we can do the query straight up and publish the keys to PubSub. Or if it's too big, we can start enqueuing them onto task queue. And that's kind of what this looks like. So for every, we chunk up the date range by, say, 1 hour, and we start posting tasks to task queue until we're done, which is very quick. And the great thing is we can actually use the same URL we used to kick it off. It's actually calling the same URL, except all we have to do is let it accept post requests. We don't have to change the logic at all, since all the data is in the query parameters. We don't have to handle a body or anything. So it's very convenient. So now here's kind of what it looks like. We kick it off. We start publishing date ranges to task queue, which calls the App Engine again, and then those query for keys, which they publish out to PubSub, which keeps fanning until all of our data is loaded. So now it's really fast. In my testing, it's managed to do 25,000 entities per second, which is actually too fast in some instances. We were actually running up into the limit of how fast you can stream data into BigQuery. But here you can kind of see it in the logs. At the bottom, there's a GET request, and then you can see the task queue tasks coming back in as posts with the date ranges. And if you click on one, you see it queried for all the keys within that date range, and it published 97,000 keys. That's probably a day's worth of scores. And yeah, so at the very end, they put 500 scores. And we can do other things with this that's really neat. We can handle solves. Every time someone solves a puzzle, we can publish out to PubSub. We grab their progress or their score, put that into BigQuery. So now we've got that streaming data. It's always fresh. Same thing, we could have give it a user ID, load a user's data. Someone complains like, hey, I should have a streak, for the past 3 years, and we could say, no, you revealed a clue in 2014, so you don't deserve a gold star. And then we have a cron job every day that actually loads the previous day's worth of data. You see the spikes. These are actually the number of instances. It'll scale itself up to, say, 60 instances, do the load, and then it's done. See the one second to the right? That one's actually an anomaly. That one's kind of out of place. The good thing about this, using PubSub, is actually very, very resilient. This actually happened yesterday. Someone broke it, and so progress wasn't getting loaded. So it kind of stacked up in PubSub. And then I fixed it, and that second one to the right is when I fixed it, and it all flooded back in. And then we can answer really cool questions. So these are the quantiles for the crossword solve. You can see if you solve a crossword in 7.5 minutes, you're in the top 1%. And if you do it in about 30 seconds, or 30 minutes, you're in the top 50. Average solve time, so the puzzle gets harder throughout the week, and it starts at Sunday. So Sunday is actually a bigger puzzle, so it takes people longer to solve. So Monday is very quick. All the way through Saturday, you can see that it gets more difficult. And this is cool. This is the mini solve times between this week and last week. This is actually for today's, so today's is in blue. So you can see that today's is actually much easier than last week's. I did today's in 58 seconds. The mini is free. You should all go and try it and try and beat 58 seconds. I'm in the 4th percentile. So, goals. Thank you.